Hi, here we will discuss about lower bounded wildcards. The lower bounded wildcards are restricting the user to specify the object from unknown type to specific type. So that object to be a specific type or super type of that particular object. It is declaring with using quotient symbol followed by super keyword. So quotient symbol is the wildcard we are using and the super keyword followed by its lower bound subclass. For example, here I am using the wildcard quotient symbol inside the angle bracket and super keyword, then integer I am using as a subclass or child class. In this representation, the question symbol is wildcard and super is here representing the integer. So integer is getting the features of integer class and also which is using the features of parent class, that is number class. But when you are using only the integer like this, it will use on with only the integers restriction integers methods or features. So when you are using the question symbol wildcard, then super and then subclass is here integer, then which is using more number of features, that means integers class features and also parent class features. So both class features are using in this program when you are using this representation. So this one is less restrictive than when you are using only the integer class alone. So here which is using only the integer class features, but in this representation it can use parent class features and child class, that means its own features. So more number of features are available in this representation. That's why we are saying here this representation is less restrictive than when we are using only the single class alone. Now we will see the example. The lower bound is the class here we are using, then method is defined here which is carrying the list interface. Here we are carrying any data type of the class, super class, parent class, then super keyword, then the class which is defining here, that it should be a subclass or child class, then which is carrying the data through this argument. Now this argument is having some elements that is passing to the some object variable. This is the object, n is object to the parent class to parent class object, okay, then which is printing the values one by one. From the main method, here I am creating the object for this array list, okay. So integer, okay, here I am using the list of data, these are integer data type. So this object is integer object. So when we are passing this values to the print method directly, which is calling the print method here, so in this context which is receiving the integer data to this argument which we are passing from the variable x which is having in this method passing argument. So now this will use the number class features and this will use integer class features. So both class features can be used inside this code. Now which is passing the values to n. So n is receiving the values one by one. First it will print the 5, then it will print 10, then it will print 15 by repeating the for loop for 3 times, because the length of the array is here 3. Then here you see we got the output for this print of x, which is printing the values by executing this method code. Then second time you see I am using the parent class. Here I am using the parent class number. This object belongs to the number class. Whatever data we are passing over here, then it will use the features of this number class. Here I am passing the float value, okay, floating point values. So here these values are passing through the class object y, right? The class is here number. So number is having the float is here child class. So automatically when we are passing the floating point value, number is using the features of its subclasses. That's what here now y is carrying these values. Then the print is calling over here. Once the print is calling here, then automatically control is passing out to the print method now, which is carrying the values 10.0, 25.0, comma 35.0. Then those values are passing to the variable al. Then from this, which is printing one by one these values what we have passed over to this object, then we are getting the output from this statement. So here what we should observe, the different data type objects can be defined and those values can be passing to this wildcard, lower bounded wildcard, right? So that is the thing here. In upper bounded wildcard, we have used the extends keyword. Okay, so here the question symbol extends, then here parent class. Okay, so but in this one we are using the super keyword here, then here subclass. In this left side of this one is quotient symbol. So this is the difference between lower bound and upper bound, right? So here we see when you are passing instead of the number float. Okay, float is not a superclass to this integer. Okay, you look at this here. Integer is the subclass to the some any one of the class. So that any one of the classes here is number as per the Java generics. In Java generics, number is the parent class, integer is the subclass. So this is accepting. But when you are passing only the float data type, here I am giving float data type, at that time it will give you the compile time error. You see here we are getting two errors. Those two errors are representing here the lower bound, that is the program name, incompatible types inference variable t has incompatible bounds. That means here equality constraints float, here I am passing, here I gave float, right, by changing the code. Then when you are passing this, right, which is taking the float equality constraints float lower bounds bound double, which is saying that incompatible types list float cannot be converted to list quotient symbol super integer. So here it will use only the numbers feature and the integers feature. Okay, but that's here the restriction should be only the methods of number and methods of integer. It cannot use another subclass, other subclasses. Okay, other subclasses float, double, short integer, long integer, this cannot be used by using this lower bound representation. So that's why we got here error in this moment. So based upon this, we have to check that the superclass only can be inherited. I mean superclass features only can be used. That superclass can have many other subclasses, those features cannot be used here. The third type is here unbounded wildcards. The unbounded wildcard represents the list of unknown type of objects, such as list. Here we are using question symbol inside the angle bracket. Now this approach can be useful in the two scenarios. One is whenever the given method is implemented by the functionality provided in the object class. If you use the object class, then in that situation we can go ahead with unbounded wildcards. And one more thing is when the code is using the methods in generic class is not depending on type parameter. For example, the methods like clearing the list, clearing a list and size of the list, and checking that list is empty or not. So these methods are not depending upon the code or any values we are receiving inside the method. So these methods, if you are using there, we can go ahead with unbounded wildcards. So example is given unbounded, then method is given here. Just we are representing quotient symbol inside the angle bracket. That means unbounded, there is no lower bound, there is no upper bound, so both bounds are not there, so we can use any bound. Okay, that is the thing, boundless, unlimited. So here we are receiving the data from the method invocation. So here method invocation is passing the x is now integer data type, so this is carrying 1 comma 2 comma 3. These values are passing by calling the method display. So 1 comma 2 comma 3 is passing over here. Now you see here I am using the object class. Okay, since I am using the object class, I can go ahead with unbounded. That's why we are using type parameter unbounded. There is no super keyword, there is no extends keyword. If you use the extends keyword, that will be upper bound. If you use the super keyword, that will be lower bound. We did not use both of them, so simply we are using the wildcard. Okay, because I am using the object class, for that I am passing the values what I have received from this method invocation. Then just I am printing the values one by one by using the for each loop. Based upon that, I got the output here, integer values, these values. Then I am passing another data type object here, string, because it will accept, this wildcard will accept any kind of data type, unknown type, any data type objects. So now here I am creating the string data type object. Through that I am passing three values in that list. Then I am calling the method display through passing this values of y. Then my control is passing over here. Now it is receiving this all three string values. Those are passing to the object class variable y. Then y is printing one by one by using the repetitive of these index values. So the string values are printed here. We are observing that we are not using super keyword to represent the lower bound. We are not using extends keyword to represent the upper bound. So which is called unbounded wildcard. Simply we are using quotient symbol inside the program. Here one more example is given by using abstract class, which is having the shape. Then abstract method I am using, so method is not having the body of the content, that is called abstract here. Then I am extending the shape by using derived class or subclass, which is having the method area. Just it is having a simple printing statement. And one more class is represented here, that is method square, which is also having the class square, which is having method area. The square also extending the class shape. Now I am defining the class wildx here, which is having method area shapes. Then this is the representation for the upper bound. Okay, quotient symbol extends shape. Here you see which is receiving the values through the OB. Then OB is passing to the variable s. This is belonging to the class shape, which is defined here. Then which is having the area is the method, that is abstract method, which is defined here. Okay, based upon that, in the main method I am creating the list as a object. In the array list I am defining the rectangle class. Okay, user defined class. Then I am calling the constructor which is adding into the list. So now list is having the constructor of rectangle. Automatically the control is passing over here. Then area shapes is the method, through to that the value is passing. So now to this list one, the content of the rectangle class is passing. Then once it is called, so area shapes is calling, the argument value is list one. So list one is having the data which is available inside the rectangle class. So here rectangle class is having list one, that here the content can be accessed by using this object. The content is passing to the yes, so using that yes, that content available inside the rectangle is area, so area is calling here. Once it is called, this is accessing. Okay, this line is printing, so based upon that, here you see area method from class rectangle, which is printed, just it is printing. If you want to use any calculations, arithmetic calculations, relational operations, or any GUI methods, here you can use any kind of code like that. One more time, I am defining the object by using another class square. Okay, this belongs to square. I am calling the constructor. Automatically the content available in this square class is passing to the list2 object variable. So this object where content is passing to the area shapes. Inside the area shapes here, which is accepting now the square class object. Previously it is accepted rectangle class object. So these are all user defined classes. Okay, now which is receiving the list2, then through that list2, now we are accessing the area. So area is available inside the square, so that square already called by using the constructor now, which is printing the statement area method from the class square. Like this we can define user defined objects by using the wildcards. Thanks for watching.